Morning, everyone. Welcome to the C&E Sales Monthly Webinar Series. I'm Jeff Butler, the Technical Manager here at C&E. Today's webinar is titled Profibus Installation Best Practices and Integration with TIA Portal. The presenter today is Howard Wong. Howard's an automation specialist with C&E. He holds a BSEE from Rose-Hulman Institute of Technology. He spent his entire 20-plus year career working with Siemens Automation, and he works out of the Evansville, Indiana marketplace. Just a few housekeeping items before we start. If you have questions during the webinar, please submit them using the control panel tool on the right side of your screen, and we'll address them at the end of the session. If you don't see that tool, click on the red horizontal arrow and it should open up a little dashboard that you can see the questions. Everyone registered for this webinar will receive a link to the recording. Please be sure to attend next month's webinar hosted by Rob Wiedemann of Banner Engineering. This topic will be Trends in Industrial Lighting and Indication, and that webinar will be October 12th at 10:30. I also want to make mention that we're hosting a Step 7 Programming 1 class. This would be Step 7 Classic, version 5.5. That's going to be held in our Dayton office on October 24th, 25th, and 26th. 3-day training class. The cost of that class is $1,500 per seat. So if you have interest in that, just contact the C&E office and they can get a quote to you for the class, or if you visit our website at www.cesales.com and go to the events area, you'll be able to see more information on that class. I'll now turn today's webinar over to Howard.
All right, good morning, everybody. I hope we're all doing well today. So we're going to talk about Profibus today. My plan is to talk about 45 minutes. And we'll leave the rest of that hour for questions. So just to give you a little more details about where I'm coming from, I've spent the last year and a half at C&E Sales. Before then, I spent 18 and a half years with another Siemens distributor, and they were also an integrator as well, so I did a lot of integration projects. But before then, I spent 2 years working for Siemens. I was a factory automation guy working out of Alpharetta, Georgia. I've got my certification for Profibus. I also have my certification for Profinet. And Siemens has also certified me for PLCs, HMIs, and networking. So I've been around for a while. I didn't just walk on off the streets. So today's agenda, we're going to do a Profibus overview. We want to talk about installation best practices. And we also want to talk about some troubleshooting tools. There's some really nice troubleshooting tools out there that can take a lot of the guesswork out of troubleshooting our Profibus networks. And then we're going to finish that up with integration with TIA Portal. So first, let's talk about Profibus. What is Profibus? Well, it's an international field bus communication standard for linking process control and plant automation modules. This is an open protocol. Anybody can make a device that talks on Profibus. It doesn't just have to be Siemens, it can be anybody. There are two main types of Profibus. One is Profibus PA. That's a low-speed bus designed for direct connection with transmitters and can be powered over the bus cable. Due to its special features, it's really suitable for hazardous areas. So anytime you're talking about intrinsically safe areas, Profibus PA is what you're going to want to use. More commonly is Profibus DP. That's a high-speed bus intended for connecting remote I/O, actuators, and other intelligent units. And that's what we're going to concentrate on today is Profibus DP. So some Profibus facts. You can have 128 addressable nodes on a network. Okay. Address 0 is typically reserved for your programming device. So even when you put your laptop on the network, it has to have a Profibus address as well, and that's usually 0. Address 126 is the default address for slaves with software address settings. These are devices that don't have the physical dip switches or dials to set the bus address. There is a third-party software you would use to configure those guys, and the default address is 126. Address 127 is reserved for broadcast address, and then address 3 is typically the factory default for many devices with physical address settings. So nice. Address 0, 126, 127, and address 3, those are typically addresses you want to stay away from when you're designing and laying out your Profibus network.
It's fine, right? He's rolling, he's got 29
Okay. So those are the addresses you want to typically avoid when you're laying out your network. All right, what can happen is if you use, like, let's say you use address 3 in your network, and that's a device that's out there and it's running. So you got address 3 and maybe you got address 7 and 8 are being used. What can happen a lot of times is that if something bad happens to address 8 and your maintenance guys in the middle of the night, they want to replace that device, and they find a device out of their spares and they open up the box and they drop it in, a lot of times they'll forget to switch the address, and since the default address is 3 and you already have a physical device that already is 3, you'll disrupt the communications to that existing device. So that's something you just want to avoid. As far as Profibus topologies go, you have an option of different topologies based on the transmission medium that you use. The two most common ones are copper cables and then plastic or glass fiber optic cables. With fiber optic cables, you can do a star topology, you can do a ring topology, you can do a line topology, or you can do a mix of all three. When you're dealing with copper cables, really you're limited to a linear topology. It's a daisy chain, one going into another, a daisy chain, a continuous line for your copper cables. Now you can do a mixture of copper and fiber optic cables together. What you're going to need when you do something like that is typically an optical link module. So this is an example here of an optical link module from Siemens. And basically it's a media converter. You can see that there's a 9-pin connector in the front for your copper cable and your fiber optic cables connect in the bottom. Why would you want to mix your copper and your fiber optics together? Well, what we're going to find out in a few slides is that when you're dealing with copper, your baud rate that you can set is going to be limited by the distance that you run your copper cable. So a lot of times your PLC may be in a nice air-conditioned control room or a PCR, and the remote I/O and the devices that you want to talk to may be in the basement of your facility. Instead of making one really long copper Profibus network and having to slow the baud rate down, what a lot of people do is they'll set up an optical link module and they'll run fiber optics from the PCR down to the basement and then convert that to copper and then network that out to all the devices. So that'll save you a lot of distance on your copper cables and allow you to run at a higher baud rate. As far as copper cables go, this is the standard cable here on the left. This is the standard cable from Siemens. It's a purple cable. Some people call it the Barney cable. It's a double shielded cable. You have a stranded shield and a solid shield, and then you have two solid copper conductors. So this is the standard cable that you use to run through cabinets, wireway, and what have you. Now, Siemens also makes a wide variety of Profibus cables for different situations. If you're going to be on a device that's going to be moving and the cable tray may be moving, you may need a flexible cable. They make a trailing cable. If you're going to have to do a festoon type setup, they make a festoon cable. They make a hybrid cable, a food cable. If you're lucky enough to work on a ship and you might be exposed to salt water, they make a shipboard cable. So what I want to move on now is to installation best practices. All right, so what this is going to show us here is that there is a relationship between the segment length and the speed at which we can set the baud rate of our network. So as you can see, the faster we set our baud rate, all right, so as speed increases going from left to right, and when we go up to 12 megabaud, we're limited to our segment length to 100 meters, all right? As opposed to if we can slow our baud rate down to 9.6 kilobits per second, we can go to 1200 meters, all right? So the thing you have to keep in mind is that you have to determine what's important. Can you run a shorter cable? If you can, then you can communicate much faster. If you're limited and you say, hey, my devices are scattered out everywhere, then you're going to have to slow the baud rate down. All right. In addition to segment length, the fastest baud rate that you can set for a network is limited by the slowest device on that network. So what I mean by that, let's take example, if we have a 100-meter segment. All right, a 100-meter segment, obviously, if you look at the chart, we can talk 12 megabaud. But let's say we have 10 devices that can talk 12 megabaud, but we have one device that's limited to 1.5 megabaud. Well, how fast can we set that network for? What's the max baud rate? The max baud rate that we can set that network for is 1.5 megabaud. All right, so it's not uncommon to see multiple Profibus networks coming out of one CPU. Sometimes you have multiple networks to separate the fast devices from the slower devices. Sometimes you'll have multiple networks so that instead of having one long cable run throughout your machine throughout the plant, maybe you have a cable run for all the devices in your entry area. Maybe you have a cable for all the devices in your exit end. So therefore, instead of having a really long cable run, you have two short cable runs, and you can increase the baud rate and talk a little bit faster. Now, looking at that chart, you might think to yourself, okay, well, great, Howard, I get the message. The message is, let's make our cable runs as short as possible. All right, now there is something to keep in mind, and that's the 1 meter rule. All right, and what happens is each certified device has a small connection capacitance, and that causes a minimal reflection. And that's normal, that's just part of what Profibus is. However, when Profibus nodes are connected closely together, they can produce a reflection that corrupts the signal. So what they recommend is separating devices with at least 1 meter cabling to induce a small signal delay so that the reflections don't add up. So you can see here on the left-hand side here, we've got an example of reflections that with nodes that are less than 1 meter apart. And you can see the signal's a little bit choppy as opposed to the signal on the right. When you do obey the 1 meter rule, the signal's a lot cleaner. So I see this a lot in the real world. I see this a lot, especially with the newer drives that are coming out. Those drives are like bookcase drives, and it's very easy to stack them right next to each other from left to right. And it's very tempting to run that Profibus cable as short as possible, half a meter or whatever. And really you want to make sure you have at least 1 meter between devices. So you might see cabinets that have multiple drives stacked together, but you have a Profibus cable that droops down from one drive to another, and that's because they're trying to observe the 1 meter rule. All right, so obviously if you buy a Profibus cable from Siemens, you're going to be covered, but if you don't want to buy a cable from Siemens, that's fine too. You just have to make sure the cable that you purchase meets this cable specification. So you have to make sure that the impedance of the cable is within a certain range, that the capacity was in a certain range, that the loop resistance, the wire diameter, the wire cross-sectional area, and your inductance per resistance meets a certain limit. And these are the limits here. So if you want to go to a third-party manufacturer to purchase your cables, you can take a look at stuff like this. All right. So now what we want to talk about are the bus connectors. And the bus connectors, guys, this is where most of the problems with Profibus communication issues. That's where I see most of the issues. So the Profibus connectors, all kinds of manufacturers make Profibus connectors. I'm going to focus on the Siemens connectors today. So they come in 90, 35 degree, and 180 degree options. All right, so here's a 90 degree, here's a 35 degree, and here's an example of a 180 degree connector. All right, sometimes, depending on what your device you're going to plug into, it'll dictate whether or not you want a 90 degree connector, or 35, or a 180. Back in the old days, Siemens used to make some HMIs, and the only way you're going to attach it to Profibus was with a 180 degree connector. A 90 or a 35 wouldn't work because there was actually a flange that prevented you from making that connection. All right. You can also purchase the 90 and 35 degree connectors with an additional 9-pin socket on the back. We're going to talk about what that socket is good for and what it's not good for. But before that, I want to point out something. So if you notice, there's an on-off switch on the back of all of these connectors. You can see it here on the 180 connector. It's down on the bottom there. You can just see it in red. That's for a terminating resistor. All right, and we'll talk about when that terminating resistor needs to be on and when it needs to be off, but it's very important. So I want to highlight and show you what that switch does. It's for a terminating resistor. So as far as the 9-pin socket on the back, it is not for use as a spur line or a T-line connection for permanent devices. It's only for use for a programming device. All right, it's only for use for a programming device. Now these, to get the additional 9-pin socket, it's like an additional $10, $15 from the standard connector, but I think it's well worth it, because what this allows you to do, it allows you to hook up your programming device at one of your remote I/O drops. So let's say if you have your CPU and it's in your PCR on the second floor, but you're down on the main floor with the operators at an operator desk and you're trying to troubleshoot something, it's really convenient to be able to take your laptop, plug into the back of one of these guys, and go online to your PLC via Profibus. So that's a really, really nice option. I've been in a number of facilities that don't use these additional, don't have these sockets on the back. And every time we go to troubleshoot, you have to walk back upstairs, go online to the PLC, do some troubleshooting, come back down, talk to the operator, figure out what's going on. All right, but again, it is not for use for connections for permanent devices. If you're listening to the sound of my voice and you've got a variable frequency drive hooked up to the back of this guy, or a remote I/O, or even an HMI, that's not a good idea, and we need to think about how we get out of this situation. All right, now, I know some of you are thinking, well, when you hook up your programming device, isn't that creating a spur line? Yes, but typically the cable is very short, and also it's temporary, and if you have any communication issues, it's not going to prevent the machine from running correctly. It's just going to prevent your programming device from going online. Okay, some tools to help us with the installation. We have this Profibus stripping tool, and what it is that it's got 2 razor blades in it at different lengths, at different depths, I should say. So you can take your cable, as shown in step 2 here, and then in step 3, you insert it into the device, and then you clamp down on it, as shown in step 4, and then you spin it around a little bit, and that will cut into the insulation, cut into the shielding, and you pull it apart from the cable, and it leaves the perfect amount of shield exposed on the cable. It's a really neat, nifty device. I think I priced it out a few years ago. It's like 60, 80 bucks. It's a really good device if you're going to do a lot of Profibus installations. All right, as far as making the connection goes, this is an example of what the connection needs to look like at the beginning and at the end of your copper networks. All right, so first off, you'll notice the turn resistor is set to on. Whenever you see only one cable plugged into this device, you need that turn resistor on. And also I want to point out that the cable shield must be exposed and lie on the metal guide that's in this connector. All right, we want the shield connected at both ends. Some people think that, oh, well, we only want to connect the shield at one end, and that's not true. We want to connect the shield at both ends. All right, and what we want to observe is that if you notice that the bus cable must always be connected to the left. When there's only one cable going into the plug, it always gets plugged into the left. I like to think about this as the outside connection and this guy as the inside connection, because when you plug it into a device, this is the outermost cable. All right, so the important thing here, turn resistor is on and the shield is exposed and lying on the metal guide. As far as connections in the middle, when you have connections in the middle, you want that turn resistor to be off. And if you notice, the cable shield needs to be exposed and lying on the metal guide as well. We want the shield connected not only at the beginning and at the end, we want to connect it in the middle. In fact, sometimes when you're in a very noisy environment, we recommend grounding that cable as it enters and exits your cabinet. So what you can do is you can strip away some of the insulation, exposing the braided shield, and you can take that shield and put it to ground of your cabinet. This is especially important when you're dealing with variable frequency drives. Variable frequency drives are terrible about making noise on a Profibus network. The older Siemens drives, the 6 SE70s, the 6 RA24s, the 6 RA70s, they were notorious for having the communication board tucked in right underneath, right next to the power interface board, and it was just a complete noise. It was just a terrible environment. So on those drives, they actually have a special place on the chassis where you can remove the insulation of the Profibus cable and take that shield to the ground on that drive, and hopefully that drive is grounded appropriately. And that takes care of a lot of noise. I've actually had a number of customers over the years, and they say, hey, you know, I've got a Profibus network and it's pretty good, but every time we start this drive, we start losing communications, and it is typically the shield problem here, okay? So what does the terminating resistor really do? First thing you want to point out is that the terminating resistor must be plugged into a powered device. Just flipping the switch on and leaving that plug dangling doesn't work. It's as good as leaving that switch in the off position. Likewise, if you turn that switch on and you plug it into a device, but that device is powered off, then the terminating resistor doesn't work as well. It's as good as having that switch in the off position. But what you can see here is on the left-hand side, when that terminating resistor is in the off position, it basically allows communications to continue flowing from the incoming cable to the outgoing cable. When you turn that terminating resistor on, it basically says, hey, we're going to stop the communications right here. It's as good as disconnecting that outgoing cable. All right, it's as good as disconnecting that outgoing cable. So this is a good example of what a network would look like. So here it's showing us that the terminating resistor is going to be on at the beginning, the leftmost port, the leftmost device here. Typically that might be your CPU. So the terminating resistor is on. Terminating resistor is on at the end of your copper network as well, and everywhere else it is off. It is off. Now, one thing that's a question that gets asked often is, hey, for these devices in the middle, does it matter which order I can make these connections? And the answer is technically no, it doesn't matter technically, but if you follow the convention, it does make your troubleshooting need a little bit easier. So what it's showing here is that you're connected to the outermost port of this first device, and then the very next device you go to the outermost port. And then you go from the inside port to the outside port, inside port to the outside port. And when you do that, it helps with your troubleshooting, because let's say this is a brand new installation and for some reason we've got no communications to any of the devices. What I can do here, since it's wired up in this manner, is I can come to this first Profibus slave here and I can activate that terminating resistor. And when I do that, that's as good as disconnecting the rest of the network, and I can see, I can isolate the network, and I can just worry about seeing if I can get the PLC talking to this first device here. Once I get that working, I may turn off that terminating resistor and then move on down the line. It's an easy way of breaking up your network for troubleshooting, but it only works if you go from the outside port of your CPU to the outside port of your first device, and then inside, outside, outside for the rest of the daisy chain. All right, so some of you might be saying to yourself, hey, Howard, that's great about having your device plugged in and powered up all the time, but we live in the real world and, you know, we've got to cycle power, we've got to work on stuff, and that's fine. In that case, what I recommend is purchasing an active termination. The active termination allows for replacing of devices, including the last device, at any time without interrupting the communications. So maybe your last device is a PC, and every so often you gotta cycle power on the PC, or it's an HMI, or anything. In that case, you can power up this active termination from another source, and it keeps your termination active, and the rest of the network can still communicate even though you do maintenance on the last device. So as far as how close can we run Profibus with other cables? So this little chart here can be interpreted a couple of different ways. If you look at the Profibus cable, let's just look at the first row here. So you've got Profibus communication cable. So what it's basically showing us is that if you've got other cables that's in the area and it's less than 400 volts AC, you need to be at least 10 centimeters away from that cable. If you've got cables that are greater than 400 volts AC, then you want to be at least 20 centimeters away from that cable. And then finally, it's showing us any cables exposed to rays, you want to be at least 50 centimeters away from that. Those cables, those can be anything, you know, if you got a cable that might get hit by lightning, then you want to be at least 50 centimeters away from that. So this is just telling us how close we can run our cable, our Profibus cable, to other devices, other types of cables, sorry. All right, so this slide, we're going to talk about repeaters. And a repeater is required for a couple of reasons. It's required when you're exceeding the length of the baud rate. So if you want to be able to talk 12 megabaud, but your total cable length, you measure it out, and it's going to be 150 meters instead of 100 meters, you may want to purchase a repeater to help you increase the length for that particular baud rate. A repeater is also required when you have more than 32 devices on a network. All right, so the two repeaters I have shown here, the one on the left, that's a standard repeater from Siemens. And again, anybody can make a device that, I'm sure there are other manufacturers that make repeaters. I'm only familiar with the Siemens ones. We can have up to 9 of these Siemens repeaters in a network, in a single network. All right, so that's a standard repeater. The repeater on the left is the repeater on the right is a diagnostic repeater, and we're gonna talk a little bit about what that will allow us to do as well. But basically, we have 2 different types of repeaters here. The first and last segments can have 31 stations max. All right, the segments between repeaters can have 30 stations max. So 31 stations for the first and last, 30 segments for everything in between. Each segment must be terminated at both ends. So here's an example of a network using all the available addresses. So you can see here we start off at address 0, that's our programming device, and we work our way up from address 1 to address 30, then we hit a repeater, and then we go from address 31 to 60, hit a repeater, and then 61 to 90, hit a repeater, so on and so forth. All right, so this kind of shows you how you can pack those addresses in. Now, this example, it shows the addresses as being sequential. That's not what you have to do. You can have your address, you can start off at address 99, 70, or whatever. I've seen certain facilities, they have a standard. Basically, they'll say, okay, every device that has an odd number, that I know that that's on the drive side of a plant. Any device that has an even number, I know that it's on the operator side of a plant. I've seen all different kinds of standards. I've seen it where, okay, everything in the 20 range is for low pressure hydraulics, everything in the high pressure range is address 30 to 40 and whatever. So you can break that up any way you want. So I don't want you to think that your addresses have to be sequential. We just did it so the math is easier to figure out. So we talked about some Profibus facts. What I want to talk about now are some Profibus myths. These are things that I've heard over the years more than once. All right, so let's talk about some Profibus myths. So first off, Profibus can only be used with Siemens products. All right, and we know that that's not true. Profibus is an open protocol. Anybody can make a device that talks Profibus. The shield of the cable is only connected at one end. We know that's not true now. We want to connect it at both ends. We want to connect it in the middle. And if you're in a particularly noisy environment, you probably want to ground your cable as it enters and exits the cabinet. I hear this one a lot. Intermittent Profibus communication faults are normal. I talk to customers over the years and they say, hey, you know, life is great. We just every so often we'll get a Profibus communication blip and we'll cycle power and we'll come back and we'll move on with our lives. Or I've heard the extreme. I've actually had customers come to me and say, hey, I need some advice. I want to create some logic so that it latches on certain signals over Profibus. So when I have a communication glitch, we can ride it out. We won't stop the machine. And my response to all that stuff is stop, that's not normal. All right, you should not have to live with intermittent Profibus communication faults. Profibus is designed to be on, solid, and very robust. If you're listening to the sound of my voice and you're having intermittent Profibus communication problems, you don't have to live like that. There's things that we can do to fix it. You should have solid Profibus communications. Okay, so Profibus cables can be run through a terminal strip in a junction box. And what I mean by that is sometimes you'll have these junction boxes out there. All right, sometimes you see it when you buy a piece of equipment, maybe it comes in multiple sections and they'll have wires landed on one side of the terminal strip in the junction box, and whoever's installing the machine will land the other side when they put the machine together. I've seen people land their Profibus cables on one side of that terminal strip and expect you to land Profibus on the other side. Do not do that. We do not want Profibus cables landed on a terminal strip in a junction box. If you're listening to the sound of my voice and that's happening at your facility, that's something that you need to address as soon as possible. That's a huge source for noise and reflections. And then finally, it's always been wired like that. I've gotten a lot of calls over the years where customers are saying, hey, we're adding this Profibus drop and we're not able to communicate. So can you give us some advice or some help? And I'll go out there and I'll look at their installation and I'll be walking along and I'll say, hey, wait, whoa, that doesn't look like the shield's connected at all over here. And they'll say, well, it's always been wired like that. That can't be the problem. Let's go to the end where we're adding our new Profibus device. And I'm saying, no. Sometimes the things, when you don't do things entirely correct throughout the Profibus connection, it can add up over time. And when you finally add another device, maybe that just pushes your network over the edge to the point of failure. So don't buy the argument that it's always been wired like that. So we talked about the overview. You talked about installation best practices. Now we want to talk about troubleshooting tools. We've got a handful of troubleshooting tools that we can use. One is monitoring with a diagnostic repeater from Siemens. All right, this diagnostic repeater is able to provide us cable diagnostics during normal operating conditions. So what can it tell us? It can tell us topology. It can tell us when there's a wire break. It can tell us when there's a short circuit in the signal lines. It can tell us if we're missing bus terminating resistors. And it can determine the location of that fault. Now that location, that fault location, it's not going to come back in meters or whatever. Basically, it's going to say, hey, the fault exists between these two nodes or whatever. So you kind of have to do a little detective work still, but still it gets you in the ballpark. And it does all this all while performing standard repeater functions. So that's kind of nice. If you need a repeater, you might want to think about putting in a diagnostic repeater and get yourself a little bit more diagnostic capability. Another option that we have is monitoring with a TH Link Profibus from Softing. All right, so this device provides comprehensive testing of Profibus DP segments. So what can this guy do? It's a stationary diagnostic tool for continuous monitoring. It logs and analyzes the Profibus traffic and network errors. Events are timestamped and stored in non-volatile memory. You can deploy multiple TH links. Basically, you need one for every segment if you have multiple segments. Information can be accessed via a web browser, and the alarms can be emailed and OPC into HMIs and SCADAs with an optional software package. All right. So these two guys, the TH Link Profibus and the diagnostic repeater from Siemens, these two devices are designed to be permanently installed in your network, and it's constantly living out there. The next thing I'm going to talk about, this is a tool that you're going to break out whenever there's a problem or whenever you're going to do preventive maintenance. This is a tool that that doesn't live on your network all the time. So this is the Profibus Tester 5 from my good friends at Softing. And this device is pretty amazing, guys. All right. So this provides comprehensive testing of your Profibus DP segments. First off, what can it do? It can be a signal tester. It can be a cable tester. It can be a storage oscilloscope. It can be a protocol analyzer. It can be a frame recorder, a trend recorder, a master simulator, and it can do Profibus PA testing with an optional adapter. And it can also determine topology. All right, topology, we talked about topology a little bit, and I kind of waved my hands over it, but topology, knowing your topology is one of the key things with troubleshooting a Profibus network. A lot of the customers that I've talked to in the past, they don't know exactly what order, how the cables are physically laid out, how the devices, which device communicates to the next device and in which order physically. And without knowing that, it really limits your troubleshooting ability. Because a lot of stuff that we do, you're going to get reports back, hey, nodes 3, node 7, or whatever isn't communicating. But if you don't know where it physically is in your network, it it doesn't really help. For example, you know, if you've lost communications to one of your devices, if it's in the middle of your network, but you're still able to communicate to devices at the end of your network, chances are your cable is okay. But if you lost 3 devices and they're all at the end of your network, then you still have to look at the cable. It could be a cabling issue. But without knowing the topology, that's all guesswork at that point. So knowing the topology is very key, and this device will go out and find the topology for you. So it does operate standalone or in PC operations. All right. The slides I'm going to show you, the next series of slides is all from the PC operations of the Profibus Tester 5. So when you first come up here, you can quickly see the status of your bus communications and the physics of the bus physics health. So a lot of times, your bus communications will be lit up green, communications is good, but your bus physics may not be so good. So this is an indication that your network may not be as strong as it could be. And quite frankly, without this tester, you would not know that. Because as far as the PLC is concerned, it can see all devices and everything's good. When you look at the bus physics, it will analyze your signal quality, and it can determine if you've got some nodes that are on the edge of failure, communication failure. So you can also check out the signal quality at each node. You can look at the signal quality and trend it over time. This is kind of nice because not only would you want to test your network while you're in an outage, but you may also want to look at your network when you're running, because there's a lot more noise when you're running and all the drives are running and all the MCCs are engaged and everything. So I would look at it both when you're in an outage state and when you're running and see what your signal strength looks like. You can look at the waveforms. You can look at each node without having to move the tester, which is really nice. You can quickly look at the station statistics and see which ones are your problem nodes here. And you can actually look at the frames that go back and forth. Basically, this allows you to look at the telegrams that are going back and forth on your Profibus network. So some of you guys may be really big into breaking down the telegrams and whatever. So you can actually go in and look at the telegrams, and there's documentation out there. I used to have a book where you can figure out what all the hex code means and stuff like that. So that's very cool. Now, if you're not into reading hex, what's cool about this tool, it will actually display your diagnostic messages in a text format. So you don't have to read the hex. It'll decipher the hex for you. So that's really nice. And then finally, what this tool allows you to do, it allows you to generate a very nice test report. And it's basically a good summary of your signal strengths, your topology, how things look. You know, this is a good device if you're a machine builder, an OEM, an integrator. You know, you go out and you commission the machine, and then before you leave, you do an analysis of your Profibus network, and then you can hand your customer a really nice document and say, hey, you've got no problems with Profibus. It looks good. For you end users out there, this is might be something good to run every 6 or 12 months just to see how your Profibus network is doing. Maybe you can identify signals that are going south. Maybe, hey, you know, we ran this test and bus address 9 just looks terrible, but when I look at the report 6 months ago, it was fine. What happened? What changed? Something changed, and you need to go address that. And it's really nice because you can get into the minutia of the physics here, and you can actually see things before they fail or when they're about to fail. If you have a weak spot in your network, it'll identify that. And I'm sure most of you guys out there, you guys know how much money you lose per hour for an outage. So if you have a communication failure, you can, you know, it costs money. So this is a really nice device. This is something I'm definitely going to put on my Christmas wish list, but chances are I'll just end up getting socks again, but that's okay. All right. So finally, I want to talk about integration with TIA Portal. And when I talk about integration with TIA Portal, we're going to talk a little bit about the how, but I really want to spend a lot of the time talking about the what. So we're not going to get into too much detail because then this webinar will expand to 2 or 3 hours. All right, so we're going to talk about TIA portal a little bit. All right, so with TIA portal, once you go into the software, you're going to go into your devices and network view. And basically, you can go in here and you configure your CPU to have a Profibus network. And you designate, you tell it, hey, how fast you want this network to talk and stuff like that. So I already done that here for PLC1. This is an S7 1500 CPU. It's a 1516 3PN-DP processor. And if I want to add a Profibus device, all I need to do is go off to the right to the hardware catalog, and we can go down to distributed I/O. And I'm going to use an ET200S distributed I/O. I'm going to use Profibus, and I just need to pick out the proper communication node here. So it's a 6ES7 151 1AA05 0AB0. So double click on that guy, drop it in there. So once you drop it in there, you can just click and drag the Profibus network over, link that device to the CPU, and it's now that CPU knows it's supposed to talk to that remote I/O device. You can then double click on this remote I/O device, and that takes you from network view to device view. And this is where you can go in and you can populate the I/O cards in this rack. So just like before, you go to the hardware catalog and you pick out your power modules, your digital inputs, your digital outputs. So I've got a power module in here. I've got a couple of digital inputs, a couple of digital outputs. Okay, so you get all that in there and you save it and you download it to the processor, and then hopefully communication comes up. All right. What really is nice about using Profibus with TIA portal is the built-in diagnostics. There's a lot of built-in diagnostics to this. And just to give you some background, how we had to do it in the old days with Classic, in the very, very old days, I did a project one time and the customer said, hey, I want an HMI screen that shows me all my Profibus devices out there, and I want it lit up green if communication is good. I want it lit up red if communication is bad. All right, so that was our task. That was my task. And so what it turns out was that every Profibus device out there has to provide at least 6 bytes of diagnostic information. All right, anything after that, it could be, the manufacturer could provide more diagnostics or not, but everybody had to provide at least 6 bytes of diagnostic information. And one of those bits in those 6 bytes is a bit that says, hey, the master isn't talking to this slave anymore. You've got a problem. So after doing all the research, I found a system function call that would allow me to pull the diagnostic information out of every one of my Profibus devices. I had to create logic that mapped it to different data blocks. And then I took that one bit out of each one of those data blocks. I linked it up to a tag in the HMI, and I could light up an HMI screen for this customer. All right, so that took about 2 or 3 days of work. Honestly, it was a pain. So, but here with Portal, they make it so simple, it's ridiculous. So we've got the hardware configuration in. When we go to the HMI and we configure the HMI, so I'm using a 7-inch comfort panel here, and over in the toolbox area, underneath where the basic objects and the elements live, basic objects, that's where you're going to get your text fields and buttons and stuff like that. Under controls, there's a tool here, and it's in the symbol of a stethoscope here. This is in the symbol of a stethoscope, and that's your diagnostic overview. So all I needed to do was click and drag that out, and the only thing I did to configure this guy was I reconfigured it to fit the screen the way I wanted to. All right, so without having to do any additional programming, I didn't do any programming in the PLC. The only thing I did to the HMI was drop in this diagnostic overview. What it allows me to do, it allows me to look at something like this. So this is a live view of my HMI screen, and you can see that the diagnostic overview is telling you something. First off, it's saying, hey, you're not talking to this S7 1200. That's fine. That's not what I'm really concerned about. But you can see that that S7 1500's got a red wrench next to it. So there's some diagnostic information you can gather from it. Well, when you click on that guy, you can drill down till you get to the point where you see the diagnostics for your DP master system. And you can see your DP master system, and it's telling me that bus address 10 isn't communicating to the PLC anymore. So, guys, man, just dropping in that diagnostic overview got me all that. Back in the old days, you had to do all the research, you had to write all the logic, you had to do the mapping to the HMI. Now something that took 2 or 3 days, you can do it in almost a few mouse clicks. So here it's telling you, hey, you got a problem with bus address 10. If it had more devices on the network and some of them were good, some of them bad, some of them would be lit up green, some would be lit up red. So bus address 10 is the problem. You go out, you fix it. And if you look at the diagnostic overview again, now it's going to be green, saying that everything's good. So I just wanted to show you what you can do with TIA Portal, with the integration, with that diagnostic overview. If you need specific directions or examples, we can talk about that offline as well. So in summary, so we did an overview. We talked about installation best practices. We talked about troubleshooting tools. We talked about integration with TIA Portal. Now, some of you may be saying, okay, well, Howard, that was great, but I want to read more. Or some of you might be thinking, hey, I can't sleep at night. You got anything to help? So there are some further readings here that you can look at. There's Profibus Design and Good Practices by the Profibus Profinet Trade Organization. Another good document is the Profibus Installation Guideline for Cabling and Assembly by the Profibus Profinet Trade Organization. And then also there's a white paper out there for best practices in Profibus Network Diagnostics by Softing. A lot of these documents you can probably find doing a Google search. If you can't find those documents, send me an email. I'll be happy to forward them on to you. So with that, we'll open this up to questions.
All right, Howard. Hey, thanks for a great webinar. Appreciate that. A lot of good information there. Currently, we don't have any questions in the question box, but we'll sit here and wait for a minute. Howard is one of 13 specialists at C&E that in his particular discipline is automation. So he works with all of our automation products, Siemens, Banner, Turk. But we also have specialists in other areas as well. We have specialists in drives and motion control. We also have specialists in machine safeguarding, vision specialists, and so forth. So if you have specific applications or you'd like to have one of the specialists meet with you, please just contact your C&E salesperson and they can set up an appointment to bring a specialist in to chat with you about an application. Okay, still don't see any questions, Howard.
Okay, well, I'll throw. We'll still wait, but I'll throw up my contact information if anybody wants to talk offline later.
Well, very good. Thank you all for attending today's webinar, and please be sure to attend next month's webinar concerning lighting with Banner Engineering. Howard, thanks again, and with that, we will let everyone go and end the webinar.
Okay, thank you, guys.